Okay, so we are going to look at evaluation, AI evaluation today. We've already done a lot talking about the different, you know, things that you can do once you have built agents. You have effectively gotten to the point of production when it comes to AI, and you can begin deploying. So we looked at deployment last week. We also looked at observability because after you deploy, the next thing you actually need to do is you need to monitor what is going on. Because if you deploy without monitoring, then of course, anything goes wrong, well, uh, you know what happens. So deployment always comes with monitoring, right? And evals is monitoring, basically. So we looked at evals. We also looked at sorry, not evals, observability, right? Observability and metrics. So basically, you are looking at how your agent is performing. It helps you to identify where you may be having issues. It helps you to fix where you may be having bugs, right? So um, that is very critical and it is very, very useful. Like I mentioned last week, right? I know how much I benefited um, from doing a bit of evals, right? In one of my projects. Sorry, a bit of observability, in one of my projects. And just using Langsmith. Langsmith makes it so much easier for you to do all of that. You don't have to think a lot. You don't have to configure a lot. You don't even have to do any custom installation or anything like that. Especially if you're using LangChain. If you're using other AI provider SDKs, then there might be a bit more work you will have to do, right? But if you are using the LangChain, all you just need to do is add the key, enable, and then add the keys. And you have the entire observability platform from Langsmith available to you, which is very, very useful. And it helps you to identify issues. It helps you to troubleshoot. That's the benefit of having something like Langsmith. So now, when you have set things up, right? Um, observability helps you to find bugs. It helps you to troubleshoot problems. But when it comes to functional issues, like is the LLM giving useful, sane outputs, right? Is it performing its function? Observability cannot tell you that. Observability will not tell you when the LLM is misconfigured and is telling people the wrong things, right? So what happens in this situation is evals. Evals is what gives you the capability and the superpower to properly assess the functional output of your agentic application. So, and there are different ways we will do that. So AI evaluation is a systematic process of measuring how well your AI system is performing on specific task. You are using both quantitative metrics and qualitative human in the loop or model-based assessments. So there are metrics which are standard metrics that you use to measure. And these standard metrics, the reason why they are standard is because you can keep them and measure across different generations or different iterations of what you are doing. So you can compare today's model with yesterday's one, right? And you can be sure that you're comparing them on the same um, reference, basically using the same reference. And that's really what those metrics do. then metrics give you numbers, right? But if metrics give you numbers, then the assessments will give you more of qualitative, not quantitative, right? The metrics give you quantitative, which are numbers, things like speed, accuracy, recall, precision and things like that, which we'll talk about what are some of those things. But the qualitative gives you a more, you know, it's not numbers, but it's kind of experiential. You can see it, how they are performing, right? So those are also very important as well. So um, the most important thing with evaluation is you must be able to determine if the model is reliable, if it is safe for you to deploy, if it has any biases or not. You also want to check whether there are hallucinations, whether you know, check for accuracy, safety, guardrails. Okay. So there are actually a lot of things that you would check for, you know, in the process of doing evaluation. Operational efficiency. Operational efficiency includes things like latency, things like um, response time, right? And so on. So throughout the entire life cycle of your application, you actually want your agent or your model, you want to be able to assess it and assess how it is performing, right? So that is the whole purpose why we have evals. And if you actually don't have evals, I think evals have become like standard in AI development, in machine learning. They are standard. Um, if you are not including evals, basically you are not following best practices. And well, nobody will work with you because there are standards now. There was a time in the past when evals could be something that you say, okay, I could try it, right? Or um, think of it like test coverage, or think of it like assessments that you do, for your models, right? So there's this mindset, for example, that some of the models that we have, or some of the tools, or some of the software that you are writing are not that complex, so probably don't need that kind of stuff. But when it comes to AI, right, there is no, it's not negotiable. Basically, you have to have evals. Otherwise, you won't really know what's going on with your models and with your tools. So typically, evals will answer questions like, did this model get its answer correct, or did your agent give the right answer, right? An agent giving a wrong answer is not, um, you can actually say that an agent giving a wrong answer is not, that's not observability issue. It's not a bug per se, even though you could also regard it as a bug, right? Because you are expecting that it should give the right answer. So, but it's not really a bug per se. It's more of um, fine tuning, if I may put it that way. So, but from a user standpoint, it is obviously a usability issue. So, is your model giving the right answer? Is it grounded in facts? And what we mean by facts, you can characterize facts by saying, okay, we are using retrieval, like a RAG, for example, to retrieve documents. Is it grounded in those retrieved documents? Because, yeah, models are trained, or LLMs are trained on data, but they can hallucinate. We know that already. And our solution is to provide them with grounding data that will ground them. So your evals is going to help to identify if the model is actually, basing its response on those grounded data that you give to it. Then things like, is the model giving helpful responses, right? Is the model giving helpful responses? Again, that is something you figure out or identify through evals. It is not something that you would say, okay, let's um, go check a plot or a graph. You will not see that in a graph, right? So that is the benefit of eval. And eval is very, very critical, um, like I said. So the types of eval that we have an automated eval. Automated evals are evals that obviously, as the name implies, they are automated. So we may not have a lot of human intervention in it, at least during the evaluation phase, right? But definitely during the preparation phase, humans will be involved. Humans are always involved. But during the evaluation, when you want to actually run the evaluation, it is automated. Now, evals are typically based on data that may not be easy for you to program. You cannot easily code it and say, this is what the answer should be. These are not precise yes, no kind of answers, right? So you may not necessarily use the, the typical rule-based system, even though there are rule-based evals, which, for simple ones where the answers can easily be expressed as rules. But for the ones that are a bit not that straightforward, you typically want to use an LLM. So LLM as a judge is an example of an automated evaluation. Then we also have a heuristic. Heuristic is the rule-based, like I said. So you are going to come up with a bunch of rules that you would then use to judge whether the performance is okay or not. And this bunch of rules will be written, you encode it, you encode it as a bunch of rules. So that is heuristic, right? Then we also have human evaluation. So with human evaluation, of course, you have a human being coming in to do the evaluation, right? So that could also be considered a manual evaluation because there's human in the loop, right? Then we also have um, the regression. Regression is comparing the current performance with a previous performance that had been measured before, right? So with that one, you are able to identify whether the model regressed or not. So those are the different kinds. Typically with something like the human one, right? What you're actually looking for is kind of to optimize it to make it more efficient because there's always a tendency for human evaluation requires human beings, and sometimes you have to do it at scale. So you have to figure out a way that you can have lots of human beings accessing your tool to evaluate it, right? So that's why, for example, in a lot of cases you see people giving um, a user interface, for example, that people can access and basically use that to evaluate. That's why sometimes when you go and see things like captchas, um, rating UIs and all kinds of stuff, that is still a kind of human evaluation, right? And I think as when it comes to design of agentic applications, especially the user interface part of it, is always a key element to add a way to rate it. But if you go and look at a lot of the pilots that we are using these days, right? You find that there's always a point where um, there's a thumbs up button for you to either decide, right? Um, there's a thumbs up button for you to decide what rating is to be given to that application. That's uh that's a benefit of or that's how we can get user feedback. Just okay. So the aspects of AI evals, when you're doing AI evals, there are certain things to look at. Like I said, there is first of all the quantitative metrics. The quantitative metrics are basically numbers, numerical data. So numerical data is effectively um, numbers that represent the performance of that model on a particular set of problems that you have already predefined. Right? That's numerical. So the typical ones that I use with neural network models, general, and in this case with our AI models, are the ones that you see here. You have precision, you have performance, you have accuracy, you have F1 score, and you have like latency. Latency is numerical. It measures how fast the model responds, right? Or how slow before a user begins, or how long before a user begins to see some response from the model. So that's the only metric there that has to do with response time or speed. But the other ones have to do with the quality or accuracy of the response. Okay. So the quality of the response, the accuracy of the response was still numeric. Okay. Then we have the qualitative assessments. The qualitative assessments are measurements that depend that are done based on not the it's not a number per se, but it is behavior. It's not something that can easily be it's not something that can easily be quantified. So we have to figure out a different way, you know, for it to be measured. And typically it is by comparison, right? And a lot of times because of its nuance, it requires humans to come in. So it will require humans to evaluate some of those, attributes that we are looking for in the response. So for example, we are looking for the tone, for the nuances, how the model is responding specifically, relevance of the response, right? So for that, typically, in fact, in both cases, you typically you create a data set and you create your metrics and then you run evaluation. So we'll look at that when we talk about it. So the types of evaluation that you normally do would be we have two broad categories: the offline evaluation, the online or real-time evaluation. The offline evaluation is that you are evaluating the model while it is offline. So that's what when you are developing the model, right? Um, you are not going to necessarily look at um, the model while it is running. Okay, you are going to just test it as part of the development process. So typically, you have a fixed data set that you are going to use, and they have some fixed benchmarks that are tied to those data sets, and they use those benchmarks. So when you run your models through those data sets, and then you see how it performs on those benchmarks. Those benchmarks could be both the numerical ones, the metrics, the quantitative metrics, or um, a measure of how well it is doing with respect to a comparison of the output, right? You have another data set of, okay, this is how the actual response should look like. Okay. Then the online or real-time evaluation is monitoring that you are doing on the AI while it is live. it is running in production or in testing mode. Okay. And typically what you are doing is you're actually monitoring real life data that is coming into the model, right? You monitor the real life data and you monitor the response that comes from the model to that real life data. And the idea is for you to be able to see if the model still continues to perform well or whether there is a tendency for it to drift. Because drift is a very real thing. It's very real, right? When we are talking about models, right? Drift is real. What drift means, we'll talk about that more, is at the beginning, a model was performing well, but over time it begins to not perform well, right? It begins to drift. So some of the metrics that we'll look at hallucination rate, which is it measures the frequency of false or fabricated information that the LLM comes up with. Accuracy measures correctness of LLM's response with respect to ground truth when you compare it with ground truth. Then you have safety and bias check, which is to ensure that the model does not produce harmful or prejudiced content. Then the other thing you look at are the context, right? So for LLMs, typically you are going to evaluate the reasoning of the LLM. You are going to evaluate generation, how it did the response generation, and then summarization capabilities. But for AI agents, you are going to go beyond that, and you are going to measure the ability of the agent to use tools, whether it's able to select the right tools, or whether it's even able to use tools. Because, by the way, what a lot of people, especially in today's world, don't know is that you actually need to train an LLM to use tools. You actually need to train and for it to know that it can use tools, it can make tool calls. So apart from that, being able to make the right tool calls, then being able to reason when it gets the response or the results from the tool calls and decide whether to do another step. So even the multi-step reasoning, the React loops and so on are still things you want to test in an agent. So well, we are going to do a bit of hands-on, even though not immediately. But if you are doing offline evaluation typically, you can run some scripts. Typically, evaluation would need you to write some scripts and then run the script. So this is an example of a script that you have run. We'll look at the steps that we normally take in evaluation. But the first step typically would be something like, um, first of all, you have to create your data set. So there's something we call a golden data set, which is data set that you have prepared and curated, which you will use for a long time to basically to evaluate your model. So you create, it takes time and it takes effort. And the golden data set is always typically made up of the inputs that you want to give to your AI agent and the output that you expect it to give out and how that output should look like, right? And then you store that, a lot of it. You cannot do evals with just a few data points or a few amounts of data. It has to be a lot. So sometimes it takes time to build. Then when you do the golden data set, then if you're doing offline training, or sorry, offline evaluation, then at every point in time, maybe when you make a change, by the way, you can even include evals. And that's something that is kind of increasingly becoming norm. You actually run a CI/CD workflow for evals, where you will run your model, you load it with those, golden data sets that you have prepared, the inputs, and then you compare the output that it does or it provides against the standard one that you had done. Okay. So typically you have to write some script around it. So this is an example of such a script. um, let's say that this app has chains already that you have created, and you have a function called getRagChain, which you have created previously. So getRagChain will give you a chain that does retrieval, augmented generation. Then LangChain allows you to bring in an evaluator. Um, Even though these days LangChain evaluation is mostly done in in Langsmith, right? You can pull in the evaluators in, and then yeah, but you can get an evaluator. We'll also look at how we can do um use Langsmith and the workflow for using Langsmith. So so we'll look at that. But in the old LangChain, this is actually kind of old code. Right now, you get this in LangChain Classical. It's not in current LangChain V1 core anymore. It's LangChain Classical. So you import this evaluator function, and then you can um, basically load an evaluator. It has evaluator, the type of evaluator, the criteria, right? And then you create examples. So here, this is the example that you want to use to evaluate. So this is just one of the samples where you are giving the model this query, and this is the expected response or the reference. It's not really expected because these are not precise, exact things, right? In evals, you are dealing with large language models, so it will not be exactly this response, right? But it should be similar. And this is where you now talk about judging it, where you will decide how you want to judge it, whether you want to use a human judge who would actually look at this response, this reference. So this is a reference of how it should look like. So you look at the reference, back propagation computes gradients to train neural networks, right? So if you're using a human evaluation, a human judge, then the human will compare what the LLM generates with in response to this query, will compare with this reference that is provided. You could also use an LLM judge where you use another separate LLM, maybe a stronger, more powerful LLM or a stronger um, model, and that is different from the one you are currently evaluating. And then you give it that same query and see what it does to compare. But you could also have rule-based evals where you are looking for some certain keywords as well. So rule-based eval would be you build a tool that basically will look for some keywords to match, um, you know, kind of similarity match. Um, you could even use something like a vector-based embedding, right? Again, and do a similarity match. So there are many different ways that you can implement this assessment. So when you have had your examples, then the next thing would be um, you would run. Of course, the rest of this code is not showing, but when you run the evaluator, right? When you run the evaluator, it's going to essentially take the model that you pass into the evaluator and run it against all these examples and compare the response from the model to this reference. And this is just examples with an array with just a single entry, but typically you should have a lot, right? Hundreds, maybe tens to hundreds, depending on how much data you can generate. So this is offline evaluation. Now, with online evaluation, like we said, online evaluation, you have deployed your application, right? And you now want to check and make sure that your model, while in production, is still giving the right answer. It is not drifting or anything like that. So this is an example. So in this case, you can see we are taking it that this is a deployed application. And because it's a deployed application, this is a deployed fast API. So a bunch of this, right? This is just an example, by the way. This is probably not the best way to do evals. But then you see that part of what we do here is to log the query input, and we log the response from the agent. Because here we already invoked the agent and passed the query to it. So when you invoke the agent and pass a query to it, um, the next thing would be what response did it give? So you're actually going to log, you have to log it, right? And typically you log this to somewhere, right? Here we are using print, but typically you would store it in the database that later on you will retrieve and use for assessment, or in a file, or in cloud storage, for example, S3. So you log this, and then of course you still return a response back, but here you are logging it. Then later on, you will now have a separate session or a separate script that will go through all these logs, replay the logs, and use the logged data as evaluation data, right? It is basically going to take the input and then um, evaluate the outputs that the LLM did. So the good thing with online is that you don't need the LLM again to generate the output for you, because you are just comparing it against the output it had generated while it was in production. And of course, this is a continuous process. So the main thing is log the um, input, log the output, log the timestamp. Then in a separate process, asynchronously, separately, you run another tool that will keep on evaluating this to ensure that the model is doing the right thing. So that's online evaluation. Okay, so this is another example here. For agent evaluation, you are going to look at several things, like we said. You're going to look at tool calls. You're going to look at its reasoning, and the ability to apply reasoning loop. So this is offline. This is a script. This same script can be used for both online and offline, right? But this is offline because you get the agent, you run you get the evaluator, and you specify what type of evaluator it is, because here LangChain gives you this very easy tool, the load evaluator. So what happens is that LangChain actually gives you a bunch of um, um, pre-canned evaluators which you can use. But these days, of course, they have moved all of that. You can't, the code itself for this, you see it in LangChain Classic. But these days, evaluation from LangChain version 1, they moved it into Langsmith. So we will also see how we can use Langsmith to do evals. But one of the most important takeaways I think everyone should take away from this is it's really up to you to write evals. It's not difficult, right? You don't even need to use LangChain, because evals is really just about create the set of inputs, then write your own framework. It can just be a simple script where the inputs that you have generated, you load each of them in batches, pass it, send it to the model if it is offline, right? And then the response from the model, you compare it with the reference. But if on the other hand it is online, that means you already have the input and the output that the model generated, and then you just run it, compare against your own reference. By the way, when you are doing online, The inputs may not always match because this is in real production, right? So the input may not match. You may not even have had an input, right? So we need to figure out a different way of assessing that, right? That's where again you could use other agents, other LLMs, or use humans in the loop, or use rule-based to assess. So this is how you do that. So at the end of the day, the metric that you want to track when you're doing evals, um, latency is important because you want to give your user a much better UX, user experience. If your latency is too much, your users are going to basically get tired of um your app and they'll leave. And you don't want that to happen. So that's why you actually need to put in some efforts to make sure it comes out well. Then the second thing is token usage. Cost is always very important these days. You are making API calls, whether you are building the app for yourself or for a company, you always need to check the cost of AI API costs or AI provider cost. So you need to watch token usage and you should have a vals, right? For the same query or question, how many tokens are being used and so on. Two calls. Two calls is really important. Um, Two calls is what results in the better behavior of your model or not. Models being able to know, um, this is for agentic, right? Models being able to know what kind of tools they should call or which tool they should call. Of course, it also depends on the tool as well, because if the tool does not have a clear description of what it does, then the model will have difficulty figuring out whether it should call that tool or not. So that's why that one is put in the bucket of agentic. The entire thing is the agent, the tool itself, plus the LLM itself, right? Plus the prompts make up the tool, right? And all the other things. Retrieval hits. This is for RAG, right? How many hits we get when you do a retrieval from the RAG, right? So that is another metric for your RAG system. It's a measure of how well your data was ingested, but also how well retrieval is happening. Okay. Then a val score. So the val score are the ones we just talked about: accuracy, precision, recall, um, F1 score, and so on. So that's a measure of the quality of the prediction. So that's it. So this is the whole stack of how you are building your system, right? Front end, we can use a fast API backend, and then um, you serve an agent or RAG, right? And the agent or RAG is made up of what? The agent rather is made up of the large language model, right? The tools and the memory. And then, of course, you have tracing and then you have evaluation. So this is the entire stack of what you should have when you are building a full app backend, the full backend, and then the front end. Okay, so let's talk a little bit about Langsmith evaluation. So a good Langsmith evaluation workflow is less about running the eval, but more about building a continuous quality pipeline. So Langsmith allows you to build that pipeline and then um, you know, set it up and then it runs. Okay. We'll try it out a little bit. Um, Even though I don't know, maybe we'll do that next time. But we'll just go through the Langsmith UI and I'll show you where and how you can set up evals. We may not have time to actually run the evals. So leave that as an exercise. So LangChain recommends that you need to think in terms of the data set that you want to use for your eval. That's the first thing. You have to set up the data set, right? And then after setting up the data set, you have to have a target function. Then you have evals, the evaluators. The evaluators are the things that you use to assess um, on each of those. So you have to create evaluators. And then experiments. Experiments are the different experiments that you will run um, using the data sets, the evaluators, and the target functions. And then you have iteration, right? So you keep iterating. So the whole idea is for you to set up an entire pipeline, right? Not just run a single eval, but an entire pipeline that allows you to evaluate your models continuously. And then you can do offline during development and online after deployment. So typically the workflow that you would follow if you want to set up a Langsmith evaluation. And by the way, this is not only applicable to Langsmith, it applies to any other evaluation system you want to use, any other eval framework. And there are many of them out there, right? We'll talk about Mastra. Mastra also has evals. In fact, almost any agentic AI framework these days has evals, right? It has that capability. So it allows you to build those pipelines. So the first thing is that you need to instrument your application. So what does instrument means? You need to allow your application to send the data that will be used to evaluate it, right? What is this data? You need to be able to implement your app. Your application needs to log. It needs to send metrics and traces, right? The good news is that you don't need to, in most cases, you don't actually need to do this yourself. Especially if you are using libraries that already have these features built in as part of, because there's a standard now, the open telemetry standard that recommends, all of those things, tracing, logging, and metrics, right, as data that should be um, continuously sent or pulled or generated, right, that can be then used to assess your application. But even at that, in your own part of the code that is custom code, it is always good to remember to do that. If you need to do tracing, it's good, right? If you need to do logging, logging especially is very, very critical. If you have exceptions and you have a try catch block, put some logging in there. And don't just use console.log or logger.this. Use open telemetry standards, right? Even though these days open telemetry will catch those things, right? But ensure that you incorporate that into your code. This is something that a lot of developers that I know are not even aware of, talk less of doing it. How many times when you run a try catch block or when you write a try catch block, do you remember to log it, right? Log exceptions. But beyond exceptions, log even, normal events. Even though normal events these days, we don't use logging to track normal events. It's kind of like what we used to do before, but you can still log it to log for debugging purposes, to log for tracking or info purposes, right? But these days, the standard is normal debugging stuff. You can use tracing because tracing always tracks the flow of the request from the point that it is made, the point that it is delivered and returns back. But then there are a few times when you want to log and log logging.info or logging.debug. Okay. So always remember to do that. In most cases, like here, you can see that if you're already using LangChain, LangChain already has all of this included. So the only thing you need to do with LangChain is to set this Langsmith tracing to true and then pass in an API key. Then the other things you could add is a backend URL, the API URL of Langsmith. I think those are the three main things, right? If you're using LangChain, you don't need to do anything else apart from this. But if you are using some SDK, maybe OpenAI or Google Gemini, like in this case, right? Then you have to bring this, you have to import the wrappers and then you have to wrap around. I think I showed that how that is done last time in the last class. If you actually go to Langsmith, you will see that if I want to you create a new account, it gives you samples of how to do it for each of the different SDKs, for OpenAI, for Google Gen AI, for OpenRouter, for Grok, for all of them, right? DeepSeek and all the rest. So you have to wrap the client, with this. So what this wrapping is actually doing is that anytime an API call, anytime you call the client, the wrapper will introduce a trace, and whenever there are issues, exceptions, and so on, it will log us as well and rethrow. So in a way, it just takes away um, you know, the burden away from you as a developer of having to do those things yourself. But I typically tell people, find a way, find a way to do it, right? Find a way to do it by yourself, because it helps you to learn, right? It helps you to learn. Okay, so that's the first step. The first step is instrument your application. Okay, ensure that your application is sending metrics, is sending traces, and is sending logs to the observability platform. That's the most important first step. Okay. Um, then of course enable it. One thing is logging in, the other thing is sending it. This langsmith tracing is true, is what will enable it to send it to an API. Without doing this, right, the code is actually still logging those things, but it's just getting lost somewhere. It's not getting sent to the API. Okay, so once you enable that, of course, that's what enables observability and evaluations, evals. The next thing is you need to build your evaluation data set, what we call a golden data set. Okay. Typically, if you want to start with a lot of examples, it may be very daunting, and you'll be asking yourself, how will I generate this much data? So you don't need to start with thousands of examples or anything. You can just start with a few, right? Start with 10, start with 20, start with 50. It has to be high quality examples, right? Covering some of these areas. So happy path means that is how normally things should happen. Happy path means the normal pathway that your code should flow, that the behavior of your app should be, right? No failures, no errors, no bad inputs from the user, no failures from the system and so on. So you have that where everything is correct the way it should be. Then you have edge cases, which are the cases, the examples that rarely happen, right? That the examples that you might not even think about. Then ambiguous questions, questions that are not very clear. Failure cases, cases that you know will result in failures. Long conversations, missing information, and then adversarial prompts. So you can even try to look for all kinds of different ways to break down your model and create such data. So you create a data set, right? Then if your system includes a RAG, then you can also include the user question. All right, examples are include the user question and the expected answer, what the answer should look like, and then the relevant documents that should be referenced, right? Or as part of that, and then metadata. So this is an example, right? Here is set up as a JSON. And you can see the JSON has inputs, question, what's the capital of Ghana, output, answer is Accra, right? Now, the interesting thing is that you start with small number of samples. As your production grows, you can continue to add more and more data. And in most cases, the more data you add will come from where the application failed in production. That's actually very good testing because when you fix the bug, it's just like, think of it like regression testing or automated testing, right? Except that in automated testing, a lot of the data that you use for automated testing are mock data or fake data. So they're not real data, right? You are just testing functionality. So you can use random values. You can use fixed values. You can use values from Faker, which typically is also random. But the difference between usual testing that you do and evals is that you are actually using real data to test, not randomly generated data, but real data, because this is semantic. It is meaningful, right? You want to see how your LLM or your agent is responding to those meaningful situations. So you cannot just generate random meaningless data, right? That's the most critical and key difference. But essentially, it's just testing. Now, this data that we are generating is what we call the golden data set, right? You pull all of this data together, right? And you continue to add more and more data. The golden data set is typically um, is a name for data set that is made up of eval data where the model was failing, right? So you keep adding it back into the data set in production, you keep adding it back, and that way your evaluation data set continues to increase. This is a recommended approach because that way it keeps your evals, your evaluation, aligned with real usage. It's not by creating maybe data that you think will challenge the model, right? But at the beginning, before you go to production, when you're still in development, you may end up having to use such data that you think will challenge the model. But once it goes into production, you have to get data um, from real life failures. Then the third thing is you have to define target function. So the target function is what you are testing, right? In most cases, you are just going to invoke the agent or the LLM or the app, like you can see here, right? You just invoke the agent. Or if you are testing RAG, you call the retriever, you retrieve, okay? And what you could do is you could evaluate just one prompt, right? A single prompt. Or you could evaluate a whole chain, right? Prompt chain. Or you could evaluate retrieval. Or you can evaluate an entire workflow, built from LangChain, LangGraph, or an entire complete agent, like in this case. So that's the third thing. The target function is basically always what am I evaluating? But you are still going to write a little script that will do that, especially if it is offline. Of course, if it is online, you're not going to really write this because you already have the output that you want to compare. But if it is offline, you have to write a simple script that you run this data through. Then the fourth step is you have to choose your evaluation metrics. Oh, by the way, this is if it is in Langsmith, of course. So you have to build your app or your agent and then invoke it. But then note that this steps also applies for both using Langsmith or writing your own evaluation locally. So the fourth is choose which metrics you want to use. And there are different metrics and different applications would need different metrics, right? Different evaluators. So if, for example, you are building a chatbot, what matters most is the correctness of the response, the helpfulness, and the tone, and maybe, who knows, latency and so on. If what you're building is a RAG, then it is the faithfulness, how faithful is a response to the grounded truth, right? To the data that was ingested. Groundedness, how grounded is the response to the data that is provided by the LLM? Or how grounded is the response provided by the LLM to the data that was ingested? The precision of context, especially for retrieval, how precise is the context? Is it pulling out exactly what you expected that you know was in the ingested data? So if the components you are testing or evaluating is the agent, then the things you may really want to look at is tool selection. Is it able to pull the right set of tools? Because there may be problems that require multiple tool calls at once. Is it able to identify every single one of them and send out the right tool call requests, right? The correctness of the trajectory as per the reasoning loop, right? If what you're evaluating or evaluating is a classification algorithm, then you have numeric metrics, for example, the accuracy and the F1. So classification is a task where you are asking it, classify this picture and tell me if there's a dog in this picture or a cat. And there are times when you need to do that, right? So in that case, how you measure success is use accuracy. Accuracy is just a measure of how many did it successfully classify divided by the total number that you gave it to classify. That's accuracy, right? But F1 is a more kind of nuanced score that is based on not just how many it was able to classify correctly, but you also include how many it misclassified in that factor, right? So F1 does that. So accuracy only includes how many it correctly classified, but F1 includes the proportion of each category or each class that it classified correctly and also misclassified. In fact, misclassified as positive and misclassified as negative. I can go into the details of that later, but F1 is more nuanced because F1 gives a better measure when the amount of data is large, the number of categories, or sorry, the number of classes in the category is much. So let me explain that. Let's assume that you have a bunch of pictures and you want your model to classify which one is one of 7 people. Let's say there are 7 people that you want it to classify, or 7 colors: red, green, orange, yellow, blue, indigo, violet, right? 7 colors. Now, the number of classes, there are 7 classes there, which are what I just mentioned. One category, which is colors, 7 classes, which is 7 different colors in that category. Now, the question is, you could just do accuracy, which is add a total of all these 7 different colors, which ones of, let's say you gave it, 100 images, and it's able to classify maybe 70 of them correctly and 30 of them wrong. So it gets an accuracy of 70%. But accuracy is not enough. Now the question is, how many of the blues did it correctly classify? How many of the greens? How many of the reds? Right? But more importantly, how many of the blues did it misclassify? How many of the greens did it misclassify, and so on? So that's where F1 is a bit better. Then extraction. Extraction is if you are extracting knowledge from the data, right? So you have a knowledge graph or a knowledge engine or something, and you are trying to extract entities from the data, right? So the useful metrics that you check there is how well it does it match. So this case is exact match because you give a sample document, for example, that contains something like the James has a blue hat. James is 6 feet tall, and facts that are in that document. And then you expect that the model, because it's extraction, should be able to extract those facts. So it's effectively the way you assess that kind of model will be to ask it questions. What color is James's hat? So that is an exact match. It has to be green or blue. It is not fuzzy. Unlike if you ask it a question like, give me a summary of this, if it is summarization, it's not exact. So whenever it's extraction, you typically will look for an exact match. And you also look for validity because you may ask it, okay, when you extract these facts, send it to me in a JSON format. And you have given it very specific JSON structure to follow. So you will want to check the validity of that JSON and compare that it matches exactly. Then if it is code, if your agent or your AI is generating code, then the way for you to measure it is you would write some test coverage expecting some very specific behavior, because in your prompt, you have asked for very specific behavior. So you write unit test And you can check that. You can also check compilation success. You can even check for linting, right? Run a script that will try to lint the code generated by that AI. Run a script that will run a unit test. Run a script that will try to compile it, and so on and so forth. So if it passes, then so those are the metrics that you can choose. Different, like basically different applications that are different evaluators. And you can see some of these evaluators are rule-based. You can actually write them, right? For example, unit tests, you know exactly what you're testing, compilation success, exact match, and so on. But some may require a bit of human judgment or even LLM judgment, right? For example, chatbot correctness, helpfulness, tone, faithfulness, groundedness of RAG, and so on. So after you are done with that, then the next thing you will do is you now set up the different judges that will judge, right? So you can add LLM as a judge evaluators. So these are additional evaluators, right? That you can use, right? Langsmith provides some reusable evaluators and integrates with the OpenEvals package. So there's a package called OpenEvals that they have built a lot of useful evaluators which you can use. And you can go and try them. These are used to judge some basic um, evaluation patterns that are common. So for example, one of the functions here is a create LLM as a judge, right? So you can then pass the prompt. So the way you create it and the way you create an evaluator in this case is you create a that instance of that type of evaluator, right? You pass in the parameters. For example, here is the prompt that you want to use. Then you can run this evaluator on the specific agent, right? Or the specific agent, on the specific agent, and then you can then compare the response. So the typical criteria that you can get from LLM as a judge evaluators, one is correctness, the other one is relevance. So some of those ones I mentioned in the previous slide, groundedness, hallucination, completeness, and following of instructions. So these are things you can put together, right? Write it in your code or even do some, you know, comparisons. Then that is LLM as a judge evaluator. So these are basically evaluators that are based on large language models. Then you can also add the deterministic evaluator, the one I call rule-based evaluators, where you are writing code for it. So these code-based examples are a JSON validator, right? This one will just use a maybe JSON dot load s, right? That will load from string and check if there is an exception. And if there is an exception, of course, then it has failed that particular evaluation. But if there's no exception, then you can do some other checks, right? To know if the validation is correct. And that's it. So it actually helps because then you are able to check things like the JSON schema. You can check regular expressions. You can check for whether citation exists, especially if you are asking for a specific structure, right? You can also check that. You can check for response length. Can check if SQL, if you asked it to generate SQL, if the SQL correctly um, generated, if it was correctly generated. Then you check if the code compiles, like I've said already. You check if the API call succeeds. So, of course, that one would be after all the other things, right, have succeeded. Then that will also, be something you can check. Okay. Um, so those are deterministic. So you can see that there are two, types of evaluators you would have there. You would have LLM as a judge, and then you will have deterministic or rule-based. And then once you do that, you can then one other thing, yes, is remember that you also need to evaluate the intermediate steps, right? There are a lot of times when people feel that you only evaluate end results, right? But that's a misleading assumption. You should be able to evaluate um, intermediate steps. The benefit of evaluating intermediate results is that it helps for you to track where the problem came from, right? It becomes easy for you to track where the problem came from. Because if not, then you end up kind of trying to do troubleshooting and so on, right? So you have to do that. So that's the benefit of using of evaluating the intermediate steps. So some of the examples would be for a retriever, right? You can put an intermediate evaluation that would evaluate whether the um, the relevant documents were, retrieved by the retriever. You could also check for a planner if your agent is a planner agent. You can also try to validate and confirm that the correct tools were selected and the correct steps were selected by the planner. Then, yeah, for tools or tool calls, you may also want to check that, the correct arguments were created and sent or generated and sent by the LLM. Because sometimes you may find that some of these LLMs are not able to generate properly. So it is something you may want to also check. And then after that, at the end of the day, you still do the check on the final response, whether you got the correct answer or not, right? These are all very, very key. So you pull all of this together, right? And the interesting thing is that, like I said, this guidance from Langsmith, yes, is what we use if you're pulling together evals in Langsmith, but they are usable everywhere else. Okay. So they are very, very important guidelines to follow. So when you have done all of that, then the next thing is run an experiment, right? And you can run an experiment by simply you bring in this evaluate function from Langsmith. So if you remember, every step we had developed some things. So first of all, for example, we have created the target function here. You have the inputs. You created a target function here. You have your agent, right, or retriever, and then we use LLM as a judge, right? You pull this from the open evals function. So you create a correctness eval, right? This correctness eval is still a function that will do correctness based on the prompt. And then we also added the deterministic. So a good example is the JSON. So at the end of the day, we now run the evaluation. So when you're running the evaluation, you specify the target, which is the function that you're trying to evaluate. This function wraps the agent that you're trying to call. Then you add the data set that you have created. Then you add the evaluators that you want to use to evaluate various aspects. So in this case, we want to evaluate for correctness, and we also want to evaluate for valid JSON. Okay. And we run it, right? So Langsmith is going to track all of this, and then you can go and view the results in your Langsmith, you know, environment. So Langsmith is going to record the scores, traces, latency, costs, failures, right? So you can run these experiments. And then after that, you can then compare versions. So comparing versions means you can modify something, right, in your app, in your application that you are trying to test. Okay. You can modify a prompt. You can modify the model you are using. You can modify retrieval, chunking, whatever. You can just modify an aspect of it, embedding model temperature. And then you run another experiment, right? You run basically that experiment again. And then last bit will allow you to compare version A versus version B across all of the metrics, right? So this is much better than manually testing 5 prompts or any number of prompts. Yeah, so the other thing, the last thing, of course, you will do is inspect failures, okay? Um, you need to check out where you have failures, see if you can, fix the failures, right? See how you can fix the failures. Um, look for the runs that are scoring the lowest, right? When you are doing the experiments, look for hallucinations, look for two calls that failed, look for where you have a lot of latency, right? If you remember when we looked at Langsmith last time, you could see that you can actually, it gives you an idea of latency. It actually tells you the latency of your API calls, basically. So you can leverage on that, and you look for that when you are going to run the experiments. Then um, where you have failures in retrieval, failures in your RAG, making the right retrieval, look for that as well. So um, check it in the Langsmith interface. Okay. Then the if you have any failures, all of the failures that you have, turn them into basically turn them into a regression test, basically, right? Um, like I said, you can actually put it in a CI/CD. You can actually put it in yeah, you can put it as CI/CD, and it becomes something that you use, right? Put it in a maybe an action workflow, for example, a GitHub action workflow. Okay, put in a GitHub action workflow, and it becomes available. So that's the benefit of it. All of this that I just talked about are things you can do, right? On the LangChain platform, but sorry, on the Langsmith platform, but you can also do it. You can also still do it on your own, right? Write your own code and do it. So there's a flow for it, which we can just take a look at it. Um, you can actually make this into one big. Um, you can actually make it into one big. Turn it into a GitHub workflow, right? That does the whole thing. You can actually do that and um, run it, automate it, make it run automatically. All right. It's actually very interesting when you do that. So I'm going to show you the workflow, how that looks like if you do all of that as a single GitHub workflow. And then we'll go and look at how LangChain does it, how we can set it all up in LangChain. So this is yeah, this is how it looks like. If you are running it as a full GitHub workflow, right? It has a lot of stuff in it. So first of all, um, everything I just said, if something changes, right, you run unit test, then you can run Langsmith offline evals, then do human review, and then you update the golden data set, and then you have the next release. But apart from human review, you can also break off, right, and do baseline, compare against baseline based on previous metrics or baseline that you have already established. If it passes the threshold, then you deploy it. But if not, then you fix it and then production traces, right? So when once it goes into production, right, then you now set up automatic online evals. The automatic online evals basically collects data which can be run offline as if it's offline evals. And that loop just continues that way. So best practices, like I said, start with a few examples, but you need to set up your eval data, your golden data set. That's always step one. Um, Always evaluate intermediate steps, retrieval, planning, tool use, in addition to the final answer, so that if something goes wrong, you will know where it started from, and it's easier for you to trace. Then combine deterministic checks with LLM as a judge evaluators. So don't just do everything with LLMs, right? You need to figure out how to do that. And in most cases, there will always be an appropriate rule-based or deterministic check evaluation that you can do. Then treat production opportunities as production failures rather as opportunity to expand your regression data set. So if there's a failure in production, collect that data immediately, but add it to your golden data set. So what that means, this is just like regression testing, normal, software test-based or test-driven development, right? You typically just, if there's a failure, you immediately take that, write a test that will cover that failure, then you fix it, right? So the same way, whatever data that caused a failure, collect that data and put it in your golden data set. And then once you fix the issue, that data will always stand as a testimony that that issue doesn't exist. And that issue, if there's a regression or drift, that particular data set will expose that drift. Okay. Compare experiments against a stable baseline rather than relying on a single score. So you should have a stable baseline, and that baseline should have multiple, um, you know, metrics that you use to measure. Integrate your evaluation into CI/CD so that any regressions are caught before deployment. So just like we now do test coverage and we add it to CI/CD, right, and do automatic, we should also have the we should have CI/CD that runs with evals. Okay. The only thing is that it's probably not something you'll be running at each time you update your PR, like we currently do with normal automated testing, mainly because of the costs of running LLM, um, LLM API calls, right? It's pretty expensive. Even if you were to have a GPU server, right, that already has the capability and you run local models and all of that, it will still be expensive. So in a way, those parts are not expensive. You can run it frequently, but those parts are expensive. You can run it maybe when the as a final thing before the model is merged. You can have a flag or a label, and you activate that label when you are ready to run, and it runs. And then when it passes, that's when you merge. Okay. Um. Yeah. So um, if you have um, you know, there are there are four well, there are four different places where we can look at retrieval quality, reasoning quality, groundedness, and task success. So those are the um parts that we'll look at. So let's go and take a look at what Langsmith gives to us. Okay, so I'm going to log in. The first thing I want to do is I will just do a very simple stuff now. I had already started it, but I'm going to complete it in this class. Just a very simple evaluation. I'm still going to use Jupyter Colab Notebook. Um, right. So so we will look at everything, right? Everything that we have done. Let me go to the drive. Uh, okay. So we will follow the steps, right? Before we go to Langsmith, right? But we'll just follow the steps. But one thing I will do is I will add a Langsmith API key so that we'll be able to see the evaluation. I'll be able to do this. So I think I already have a project going here. I will now go and get an API key. So you get it from settings, API keys. I'll create a new API key, service key. Um, I can say code um, AI evaluation class. Okay, I'll let it last for maybe 90 days, 30 days. Um, then I'll copy the key and so I already started on this. I'm going to create a .m file. So note that this we can do um, we can do it with JavaScript as well. So this is not specific to Langsmith API key. So I'm going to put this here. Now, of course, this is not the only thing I need for me to enable. So remember, we will first of all have to, if we start from step one said we have to enable. So we have to enable with Langsmith tracing true, right? So I will I'll set this to true value. Okay. Um, then because I'm going to create a model, I'll go and get my usual I'll go and get my usual API key. Let's say I'll use a Google Gen AI. Because I'll just create a simple agent. I'm not going to create a retriever. I'm not going to do a RAG. A RAG is a slightly bit more involved. So what I'll do is I'll create just a very um, simple LLM agent, maybe with one or two tool calls um, that does some mathematics and a few things. Okay, so okay, so I'm going to do a Gemini. So we have Gemini API key. All right. We can add the model name as well here. So let's add the model name. Um, so this time model name, I'll use a full LangChain provider and model name. So we use Google underscore Gen AI Gemini dash 2.5 dash flash. So that's what we are using. Okay. I think that's all we need for now. I'm not doing RAG, so I don't need any embedding or anything like that. So I've already installed OpenEvals, pip install. I bring in LangChain. Let's bring in everything else we need. So we will need LangChain agents. Let's just create agents. Then tools. We'll import the tool annotation. Then uh okay. We also need to install the LangChain Google Gen AI apart from OpenEvals, which has already been installed anyway. Um so Google Gen AI should be able to give me this. Let me just create um get LLM. So um get LLM, I will just create a new LLM or get agent. I'm not going to do get LLM. I'm just going to do agent straight up. So agent equals create agent, right? And then we will use a model. We will use oh, I need to yeah, os.get env um model name. So I think we have that already. Model name, yeah. Of course, so I will have to import OS, and I'm going to import from .env, import load.env. Then we'll load.env. Um, okay, so we'll create an agent. Tools. We'll just have get tools. So we'll just have a function that will return all the tools as a list. We can have system prompt. System prompt. We can have a system prompt is system prompt. If okay, let me just do that here. So I can pass get agent and I can pass system prompt here equals none. In case so we'll have a so we can say if system prompt is none. Yeah, so we just use that as a system default system prompt. So we'll pass that in. Okay. Okay. So I think we have everything. We have the get tools function. I need to define it. Um, okay. So this can just return the agents directly. Okay. Let's create the tool function. So get tools. So we will just do two and calculate um calculate pi. So this will just return, yeah. So that's one tool. We can have another tool, um get temperature, city string. Okay, so we can just return a value, um maybe let's say 84 degrees centigrade. So calculate pi, get temperature. Uh, so for long chain tools, we actually need to add descriptions. Otherwise, it will throw some exceptions. Okay, so I'll just end with those two tools. Maybe I can add more later. All right. Okay. Right. So we have a function that will give us all the tools. We have a function that will create the agent based on the model name. It will load directly. I've already specified the model name. Um, JSON valid. This one we are using it for eval, so I don't need to make a tool. All right. So we now continue with the the guidelines. So the first guideline was setup evaluation, right? So setup evaluation basically is setup tracing is true and Langsmith API key. So we've done that already. Yeah. It's already in our .m file. So it's in the .m file that you do that, right? You don't need to do anything else more than that. As long as you set in your .m file and you load .m so that your script code will access those um, environment variables, then you are good. Okay, now the next thing is we will so build a representative evaluation data set. Now I'll just do a few cases, right? Because we don't have time to generate all of this, and I don't really have a data set. So I'll just create maybe in sample data. Um, there's actually some bunch of sample data here, but this is not optimized for what we want to use this for. So this is really for machine learning, not for AI, which is quite interesting. MNIST and California housing prediction. Yeah, but um, let's create a new folder. Let's create a new folder and we'll call it eval data. So we could just have it in a single file. Yeah, let's create a JSON file in here and call it sample.json. So we will open sample.json and then in this sample.json we can add some sample data in JSON format, inputs and outputs. So let's see if I can um, get a few. Maybe I will ask. Let me see. I'll ask Copilot to generate. Yeah, Copilots are really good at generating data. So I will ask Copilot to generate for me. And yeah. Um, yeah, I'm going to just ask a Copilot to generate that while okay. So yeah, so let's look at this. This is I have it now. So I have a sample, right? So if we look at this, you see, let's just take a look at what we have here. So we have this, it was generated by, but so it's added a bit of JSON fencing, which I'll remove because this is just plain JSON. Okay, so you can see the sample data here. Inputs, question, outputs, answer, metadata, category instrumentation, difficulty, easy. So it's generated that another one, inputs, question, outputs, answer. Um, well, from previous stuff that I did. So that's interesting. Okay, so anyway, I'm going to just save this and so we now have eval data here. So that's the second step, right? You have to have the eval data typically in this format, inputs and outputs. Then the next thing is you now define your target function. So in this case, my target function is just I'm not going to do the retrieval. I'll just do a simple invocation of that LLM. So what we will do is we will first of all create the um, yeah, we'll create the function. So we'll just create the app get agent, right? And that's it. Then the function to answer the question, yeah, we'll just do app.invoke because yeah, and it's as simple as that. Yeah, this needs to be passed as messages and the question. We can actually add other things. For example, I did not put in memory and checkpointers and all of that, but we can add all of those if you want. So that's the third step, which is create that, and that's it. Then we'll choose evaluation metrics. So maybe correctness, correctness, helpfulness, tone, and all of that. So we'll go to the next step where I'll just use the correctness, okay? And then I'll also choose the JSON validation. So for correctness, we already had it up here. I had already created this, so I'm going to create a correctness eval. So this correctness eval is going to be derived from using the open evals these open evals, right? Create LLM as a judge. So we'll just create LLM as a judge. And then we'll pass a correctness prompt. So we'll have a separate prompt that we want to pass in to use. So create LLM as a judge. And then so it has parameters, right? The first is prompt. I think that's the most important one. The prompts that we want it to access. So we can say correctness. Okay. Of course, we have to establish this prompt. So let me just put it here as a constant. And let's see if we can get let's see. So the correctness prompt judge the correctness of the response from the model compared to the provided values. So I have a prompt here which has been, let me put it in here and just call it. So I'm going to create, I'm going to create a new file here. Correctness prompt. So correctness prompts, and I'm going to post this. So you are an impartial evaluator assessing the correctness of an AI assistance response. So this is just a prompt which I asked my to generate. Okay. So return your evaluation in exactly the following JSON format: score and reasoning, right? So this is key. So that's the correctness prompt. And then we will load this. So let me use that one. So we'll use FS um, with um, open, um, not eval data. Oh, okay. Yeah, I guess we can do that. Correctness dot prompt dot txt. Um, data set equals read. Um, Okay. Um, Let me just confirm this. Okay. Um, all right. So, now we'll add the correctness. So add the correctness. Okay. So now we'll get the data set. So the eval data set. So what we've done so far up to this point is um, evaluation metrics and getting the evaluation metrics. So I have two now, the correctness and the JSON. So the next thing is um, LLM as a judge. So I've done this LLM as a judge now, which is this. So we have then we've added the deterministic evaluator. So we've done up to step 5 and step 6, which is what I just did now. This is my step 5, the LLM evaluator. This is my step 6. I already had that here. That's this JSON evaluator, which just takes the input and tries to JSON load it. And if it succeeds, then it returns true. But if it fails, if there's an exception, it returns false. Okay, so the next step is evaluating intermediate steps. Well, I won't do this because I don't have a lot of intermediate steps unless I want to reach into what's going on in the agent. But since it is just a single agentic call, there are no intermediate steps. Then we just run the experiment, which is this point here. So we need to load the data set. So to load the data set, we do eval data sample.json. We now load and we load the JSON data set, and we can look at it. So you see all the inputs are here. So we have the data set. So with that, we can now run our evaluation using Langsmith's evaluate method. So let's run it. Um, yes, so there is a required positional argument target. Um, so target is supposed to be a positional argument. Maybe I'll just go with that. Yeah, I'm just double checking. Things change really fast with yeah, okay, so this is correct now. Um, okay, so this data set needs to be converted into um it needs to be converted into a into Langsmith's current format, right? So So I'm going to go check the documentation, Langsmith, um, to this needs to be converted. The data set needs to be converted into Langsmith data set format. What I have here is just a list, and it's not fitting in. So typically you would get that from their. So let's see. Okay, now you can actually go to if you go to Langsmith, you can go check their evaluators, and you can go check their data sets and experiments. This is doing it from the UI. So it for you to do an experiment, you need to create a data set first. Then you can run an experiment. Um, so this is more or less the sequence we just did. We already have API key, we have Langsmith, we have open evals, we have Google Gen AI. These are the dependencies, right? So okay, so let me use this, right? Um, so first of all, we are using our own correct. Let me use LangChain's correctness prompt rather than my own, or rather OpenEval's correctness prompt rather than mine. Um, so clients and wrappers. Um, so we already have LLM as a judge. Um, and then we have the prompts. Okay. So we create a data set. Um, I already have a data set anyway, but let's go ahead and use LangChain's example. So I think that's the main difference. My data set is not structured. I need to wrap it in LangChain's wrapper. So, but let's do that here. So we use a client and we create data set. And I think this is a sample data set from um, uh, okay, so this is writing. It's trying to write and it's not giving me the opportunity to write. Um, so this is slightly different from what I have. Um, yeah, so I have the target already. I don't need to do that. I can use the evaluator and run the experiment, but I still don't have the data set, which is the main um, issue. I went there to, so let's see. Correctness evaluator is I already have a correctness evaluator, create LLM as judge, which is what we just did here. It's just that my data set. So I already have this create LLM as judge with a correctness prompt, which I also already have. So I don't need to use yes. The model, I can specify feedback key. And okay, so running evaluator, which is what I did here, inputs is a dictionary, output is a dictionary, reference, output is a dictionary. So this is a different approach, right? The evaluator is calculating. Okay, so let's use a different approach then. Um, I think we should use inputs, outputs, and the reference outputs. But this means that we have to change our data format because our data format had let me ignore this for now. Our reference does not have our own format. This is for inline evaluation, not oh sorry, online evaluation, not for offline. What I was doing initially was offline, where you would call the app. But what they have in their own example here is online evaluation, where you are actually collecting the data and then you would run evaluation or run the experiment. And the evaluator is correctness evaluator. Uh, yeah. So, okay, let's reduce this to just for the sake of demonstration. I'm going to remove all of this, and I will just work with a single input, a single output, because yeah, Langsmith has a lot of capabilities, but let's just simplify. All right. So again, we want to evaluate. Let's reduce this to just a single input and a single output so that it's easier for us to so typically let's reduce this data set had a whole bunch of so yeah, so what I'm saying here is that this data set is it has to be an ID. Um, it has to be an ID, data set one. Yeah. And we will use the client. So we have to create a client, the Langsmith client. Yeah, their API has changed again as usual. So I have to go to their site to check it. Um, okay, I think I know where the problem is coming from. Um, First of all, let me ensure that my LLM as judge is using the right model, because I think that may also be an issue. Um, since this is an LLM based model, I have to tie it to a model that I have, and I have the API key for it. So, um, okay, yeah. So we still have a 403. I think I need to get an API key. I already have an API key. So let's go back to this. Let's create a data set. And we'll create a data set with the same name as what we want to use here. And I should get a 403, but I'm getting a 404. So that's why I uh, so I'm going to try to add data set. Uh, yeah, this is it's a bit yeah, it's but let's just do a simple one, right? Let's just do a simple a one example data set, one example. So we can either we can just let's have an input. So inputs will be query. Um, what is the capital? What is the first capital of Nigeria? Okay. Then reference output to look something like, typically you would say input and then you say output and then you give it the um so the inputs you can have question or query or whatever you want to call it. Then the outputs um again answer. So you have flexibility to call call any name, right? So I create inputs, right? The inputs in this case I have only one. And then the outputs I have only one as well. And then I submit. We can add metadata as well. We want to add metadata. So for example, category, it's current history. So let's say category is history. Uh, so I add that. So I have data, I have a data set now that has just one example. I should be able to pull this data set from my Langsmith account, even though now I'm getting a 403, so I don't know why. Maybe because I don't have the data set yet. Okay, but yeah, so let me copy the ID. I don't know if I am using the wrong ID. Um, maybe that's why. So I'm still getting a 403. Um, so even with yeah, evaluate or client.evaluate, They both give me the same error. So I'm going to try to see if I can solve this. Um, yeah, Langsmith. But the principles are the same anyway. That's sometimes the API has changed again. Ideally, I should be able to pass in a local data set into this rather than trying to create, because what Langsmith is doing is that making it so you can do it all from the user interface, right? Without having to do stuff. So for example, in this case, I could actually do an experiment, right, with this. Either I run it in an SDK, run it in Playground, or run it in Langsmith Studio. Now let's see, I want to run this in Playground. So I have the input, the query, and the answer. Um, I need to first of all create an agent. So I create the agent here. So Landsmith Playground actually allows you to set up the agent just by specifying the prompts. Okay. So yeah, I think the 403 might be because it is somehow not reading my Landsmith API key. So maybe I need to check it and confirm that it's coming through. So we'll get back to do that. But let's try the user interface. So here I would need to create, for example, I can do a Google Gemini and I can choose 2.5 Flash. Then API key name is this. I will have to load it, right, as an environment variable. Yeah, so I need to go set up environment variables somewhere. Then I can, um, yeah, helpful chatbot assistant. So, and then query. So this is using the playground, which I wanted to do later or not now. Okay, so I can save all of this. Um, so I've set the system prompt, I've set a human query that will come in, and I've set in the experiments, the additional information. I can then start, but I will need to put in the API key, which so I'll just paste it. I think I have it already. Let's see. I'll paste the API key. I already have the API key from my Gemini, um, my Gemini Studio. So I'm just going to paste it. Good enough. They don't make it. Yeah. So I paste the API key, and then I can run the experiment. So this is doing it from the user interface. Let me resize this up a bit. So it's done. Um, okay, so now we can go and check here, right? This is a query, and this is the reference output that I give, and this is the actual output. The first capital was Lagos, right? So this is kind of generating online. So you can see it has generated this. Okay. And you can then do um you can do multiple experiments. So you can add more data and um add more different data, and it will run the same thing on all the data, right? So this is a value you can set up online. Basically, you through two steps. The first step was go to evaluators, um, go to data set and experiment. Go to data set and experiments. You first of all create a data set, and then when you create a data set, I can add this more stuff to this data set. For example, here, I can edit this data set, or rather this example. So I can add another example to this one. Um, you can bulk upload. So again, the examples have to follow kind of this format. Query, even though you could use a different structure. Um, so a question like who um amalgamated uh Nigeria into a single country. Then your reference again would be answer. So you follow the same structure. Um, metadata again, topic is history. Submit. So I now have two in my data set. I can go back to the experiment. So I'm not adding a new experiment because I already have an experiment. I go to this experiment tab, and so there are two experiments that have run. I can run another one, or I can go visit this one. So experiments. I should be able to run this experiment. So here you can see error rates 0. This is now a metrics that you can see latency, error rate. So Logsmith actually allows you to see how well it performs. You can compare. Now the evaluation of it, we have not done evaluation yet because we did not specify evaluators. We did not specify evaluators, right? I only have the examples, the data set, and the experiments. I can add another experiment here, which I can run in the playground. Or I can just go to playground and I can open previous experiments. So now this particular one, my screen is really small. Um, let's see. Uh, let's go to a slightly larger screen. Okay. So on a slightly larger screen, I think you can see a bit more things. Ah. All right. So I have added, so I can play start and it will run, and yeah. So we have this. So now we don't have evaluator. So even though we have outputs, it cannot evaluate. So we can add an evaluator here. LLM as judge, code evaluator, compose evaluator. There are many different evaluators, but let's just go with the LLM as judge. So for the LLM as judge, we can choose the correctness, right? So we can choose the correctness. And in this correctness, there's already a prompt here, so I don't need to, or I can pick a correctness prompts. Let's see if this is a correctness prompt. Okay, so correctness evaluator. This is a generic prompt here. All right, this is a generic prompt, system prompt. Um, but you can also load prompts from you know the correctness prompt. You can also load it and put it in here. But I think I can use an existing one instead of let's see. Yeah, so here are pre-built evaluators. This is if you want to make your own custom evaluators. So you can choose either LLM as a judge or a code evaluator, a composite evaluator. But you can use they have a lot of pre-canned evaluators as well. And they're all LLM as a judge evaluator. So I'm going to just take the correctness evaluator, which is already here, and the prompt matches that for correctness. Um, I'll choose the model I want to use. I'm not using GPT-5.5. I'm going to use Google Gemini because I already have the API key that I had set up already. So I will save this one. So input and output. All right. And I'm going to just save this. And the API key, I'll still take the one we already had and I'll put it here. So let me just take that one and put it here. So this is kind of API key on the fly kind of thing. So I put in the API key and that evaluator has that API key now. So let's save it. So we now have an evaluator, okay? And because we've added an evaluator, you now have a column for that evaluator. So I can rerun it now. I click on start and I can rerun it and we'll now see the correctness of evaluator will also run after the output has come through. Since it is an LLM, it's going to take a bit of time. So here you see it gets a 0 score. Um, it gets a 0 score. Right. It's funny that the LLM evaluator also kind of, but I'm surprised that the Lord Lugard okay, it gives you a score of 1. So this one is correct. While here it gives you a score of 0. So I can add other evaluators as well. I can add assertion, hallucination, conciseness, and all of that. And we can just keep assessing it. So this is doing it from the UI. Unfortunately, they have changed their API. So this is I'm getting okay. I think the problem might be that my API key is not going through. So let me troubleshoot that. Um, yeah, let me get the Langsmith API key. Okay. Um, yeah, we have the API key. So I'm surprised. All right, surprised. I'm getting a 403, but a 403 means I don't have access to it. So I probably need a different API key. Or they are basically it's saying I don't have access to this API.smith.langchain examples. I don't have access to this, which is interesting. So I'm going to go and check this and then maybe I'll do a correction later on. But they've changed their API. This is probably an old thing. So now, but you can do your checks. Actually, after having set this up, you should still be able to pull it out from, you know, code and run your experiments from code. But yeah, this allows you to run your experiments here. The the good news is that this allows you to set up your agents, right? Very easily, simple prompts like this. So if you want to really test, this allows you to test prompts basically that you are using to build your agent. You can then add another message to the prompt. If you want to chain it, you can add a specific output schema if you want to do structured output. And you can add tool calls as well if you want to add tool calls. So this allows you to add tool calls to it. And when you save the tool calls, then you can test. So Playground is very powerful. Playground is not the only place you can run your experiments. You can also run experiments in other places. So if you add, you can run it in SDK, um, right? So I think this is where mm, it still basically does the same thing, right? But you can come and check the SDK. This um, has this is still kind of the same thing, right? You still use a client to run evaluate, but evaluate comes from Langsmith. So the code is the same as what I have. I just don't know why I am having a dataset name is dataset1, which is what I used. The evaluation is correct. Evaluators are correct, right? But I am getting a 403. So I'll check this out and then maybe I'll give an update later. Okay, that's all for evaluation. Are there any questions?